Our next speaker and who's going to close us out today is Dr. Ronald Ashri, the CEO of OpenDialog. Ron is the lead architect of OpenDialog and, as I said, the CEO of the company. He's got a Ph.D. in computer science, artificial intelligence from Southampton University. He has deep expertise in multi-agent system theory that underpins the OpenDialog architecture. He has more than 15 years experience in enterprise software product and consultancy, working on large-scale knowledge management and the data analysis challenges that are required. Since 2017, he has focused solely on conversational AI, most recently publishing the AI-Powered Workplace, how artificial intelligence and data and messaging platforms are defining the future of work. Ron, are you there? All right, why don't you go ahead and start, and they'll get that on for you. I'm sure they're working on it right now. Can you share your screen?
Yes, it's getting warmed up.
Okay.
Okay, I think we're good to go. Yes, can everyone see that?
You see it, yep. Take it away.
Perfect. So I'm going to talk about how can we build conversational applications that work smarter, not harder, and hopefully be able to explain a bit more about what I mean by that. Jeff, you did a great job introducing me, so I will skip all of this and dive straight into it. So what's the challenge that we have? What's the conversational AI problem that I think is at the core of a lot that we're facing? Well, ultimately, creating great conversational experiences is just objectively hard. There is a lot of low-level machine learning work and a whole range of different AI techniques that need to come together. And then it has to go further up into conversational UX. And you have also issues such as copywriting and design and content governance and all the usual problems you have when you're trying to do digital applications of any sort. So where this leaves organizations is that they're kind of trapped between, okay, should we really embrace all this complexity and embark on large digital transformation projects where outcomes are not certain, and only if you're an organization of a certain size, a company of a certain size, can you really dive into that? Or do we go down a path which is much more simplistic but safe, and we're essentially using cookie cutter solutions, we're taking off-the-shelf products, and that can be useful up to a certain extent, but you're not really realizing the true potential of conversational AI. Now, this situation exists to a certain extent also because tooling itself, the tools that we have available to build conversational applications, are kind of stuck between, it's either machine learning and you're either doing single intent training, so something like Dialogflow, and then you're trying to stitch them together into a broader conversation, or you give up and you say, right, I'm just going to do an FAQ style bot and it's pure question answer responses, or you can do some dialogue training using a tool like Rasa, but there already you're diving a bit lower down into the more complex machine learning side of things. And you are lacking a broader context, which is the limitation of machine learning in many ways, of what is the actual contextual setting within which a conversation develops. Now, on the other side, you have flowcharts, and there's lots of tools out there that will let you build kind of decision trees of some sort. If this happened, then do this, and so on. And they're nice because they're understandable, but they're limited. They're very hard to scale, and they're particularly hard to keep evolving as your organization evolves. And they don't really deal with uncertainty. It's fixed paths you're going to go through to achieve something. Now, the question we asked ourselves is, well, what do we do about this? Do we keep working harder and harder, which is keep going down this machine learning route and try and solve more and more problems through data-driven AI models? Or do we see if there is a way that we could work a bit smarter? And I think something that's really interesting, even in all the presentations we've had today and so on, is how often do we really ask ourselves, well, what is a conversation? What is the problem that we're trying to solve here? After all, this is conversational AI. And more specifically, what is what are the types of conversations that we're trying to build here, where we're dealing with coordination, cooperation between machine and human being and problem solving. So as we were working within Green Shoot Labs, which started out as a conversational AI consultancy, and working with clients to help them set up their conversational AI strategy and help them use the plethora of tools that are out there that help you do conversational AI, we realized that all these tools didn't really provide an answer to that core question. Well, what is a conversation? What's my conversational model? How do I think about this world and then pull in technologies in order to solve specific problems? And one analogy I use to describe this is, think about trying to predict the motion of an object without Newtonian physics. Right? So you take a ball and you drop it and it's going to bounce, and you can do that 1,000 times, and you can then start making some predictions about how high it's going to bounce based on what sort of ball it is and how the ground is shaped and so on. But you're lacking a deeper semantic context of what is actually going on here. And that's the semantic context that Newtonian physics gives us, right? It talks about forces and reactions and gravitational pull and all of that. So is there something equivalent? Is there a deeper theory of conversations that we could pull in to the conversational AI space, not to make all the other tools like machine learning techniques and so on redundant, simply to reinforce our understanding and put us on a stronger footing so that we can use them more confidently? So that's the approach we took when we started building OpenDialog. And it's really based on 3 insights. Now, Jeff, you mentioned at the start that I did a Ph.D. in something called multi-agent systems. This is a really interesting subfield of AI that don't necessarily hear that much about. But what multi-agent systems, the problem it tries to solve is, it says, if I have multiple interacting software entities, each one of which is autonomous, independent, heterogeneous, and so on, how can I get them to work together in order to solve a problem? So they have to communicate, collaborate, coordinate to solve a problem. And if you think of it, what is a conversational application? You have a number of different entities, at least one human and one software-based, and they need to communicate and coordinate and collaborate to solve a problem. So the first question we pose ourselves is there anything from the field of multi-agent systems that we can pull in to help us build more robust conversational AI applications? At the same time, let's think about how we structure conversations to handle these issues in the real world. And finally, we need to put all this in a platform, in a tool that supports collaboration across the entire customer experience team and helps them to proactively manage conversations. I'll talk a bit more about what that means. Now, for that first part, how do we think about conversations where we need to coordinate, cooperate, and collaborate, we literally went into multi-agent systems research and looked at a number of different papers and so on. And we hit on this concept of electronic institutions that we thought is particularly relevant. So what electronic institutions say is they take the idea of conventional institutions, so institutions that we have in society, and they say, well, they are organizational structures for coordinating the activities of multiple interacting individuals. So let's take that idea and provide a computational analog to it so that we can coordinate the activities of multiple interacting software agents. Now, we take this idea of electronic institutions and simply say, well, it's not either individuals or software agents, it's the two of them together. So you can have humans and you can have software agents, and we need to coordinate their activities. Now, this is all a bit theoretical, so let me take you down this thought experiment. Imagine yourself in a country where you don't speak the language. So for me, that would be something like Germany. You walk into a restaurant, and let's assume that the staff in the restaurant doesn't speak your language. So you have no actual means of directly communicating. How likely do you think it is that you would actually be able to get a table, get a menu, order? Perhaps you're not going to order exactly what you wanted, but pick a dish, eat it, pay, and leave. Right? It is extremely likely that all of that can actually happen even though you don't share a common language. How is it that we're able to do all of this? It's because we share a shared understanding of what a restaurant is and how it's supposed to work. So when we walk into a restaurant, we assume a role. We become actors in a way. And we say, right, I'm in a restaurant and I'm a client. There are certain expectations about how I'm supposed to behave here. I'm going to tell them how many we are in our party, and I might just signal that. They're going to show me to a table, so I'm not going to be surprised when that happens, and I'll expect a menu to show up, and I'll pick something, and I'll eat, and I'll pay, and so on. And everyone plays their part, and there might be deviations from that script, and we will try to recover, but we recover within the context of the thing that we're supposed to do, right? So I know that I can't pay before I've even eaten or something like that. That is what an institution is. And that is what we use every day to figure out what we're doing, right? Even what we're doing right here, there's an online conference, there's a presentation. This is an institution. This is how this thing is supposed to work, and it plays out itself. And institutions can be informal or they can be quite formal. So if we're talking about a court of law, there are very rigid rules, and you might be told, well, if you don't stand up when the judge walks in, you will be held in contempt of court and so on. So we take this idea of electronic institutions and use it to build conversational applications. Then I'm not going to spend a lot of time on these Dooley graphs. I'll just mention that the other piece that we found that was really interesting from multi-agent systems research, and it's actually a round trip from linguistics through multi-agent systems research back into conversational AI, is this idea of using Dooley graphs to represent the state of conversations. This enhanced Dooley graphs were specifically designed for multi-agent systems. And we pulled this into our tool as well so that we can describe conversations in the most interesting thing for me is that we can describe them in a way that humans can interact with those descriptions and design part of those descriptions. And at the same time, the machine can reason about them and can reason about the state of a conversation in a very generic high-level way. and kind of drill down and reason about the semantic state given a specific scenario. So the end result is that you end up with this graphs of interconnected phases, and you can sort of imagine, I'm not going to go into the full details here, but you can sort of imagine how conversations evolve, and you have different scenarios, different conversations, different scenes within those conversations, different turns within those scenes, and so on and so forth. So to summarize all of this, and this is where I'm making statements that people can really challenge. From an open dialogue perspective, we think that machines cannot fully learn conversations. If we say machine learning is going to save us, we're going to be sitting around for quite some time. That doesn't mean it's not absolutely necessary. It's just not the only answer. At the same time, conversational applications cannot be fully designed by humans, right? So if we say, well, machine learning is no good, but we're going to get conversation designers and they're going to map everything out, that's not going to scale either. We need machine learning automation, we need conversation design, we need semantic context handling, and that's what electronic institutions bring into the game. And we need to tie all this together in a tool that actually works with us, reasons about the conversations with us. Again, the analogy that I use here is if you think of a computer processor, this really complicated piece of technology that has millions of transistors in it, billions of transistors, it is a human-machine collaboration that brings that together. So you have a processor architect that works on it, and then there is machine reasoning that helps tie everything together. So at the end of the day, OpenDialog is kind of hybrid AI combining the best of all worlds and proactive. So just to wrap it up, I'll show you a bit about what the product looks like, what the tool looks like. It is at the highest level, it is tooling, and that's fine, we need tooling. But crucially, it's tooling with methodology, because we think if you don't have that methodology, you don't really have any help in how you're supposed to do this. To create what we like to call smarter conversations. So instead of saying, well, we need more data, we need more machine learning to come into it, we say, let's put a framework in place that actually is going to give us some context so that we can reason about these conversations and then pull data into it. In terms of how we use AI technologies, we're not trying to solve the NLP problem. We pull in, because we break up the machine learning problem into lots of smaller problems, we just pull in whatever is required at any given stage of the conversation. It gives you this idea of proactive conversation design. So the conversation designer is thinking out, well, how should this develop? At the same time, the tool is telling you how it could best develop or what you've missed and so on. It deals with orchestration, personalization, and you can do some really interesting personalization on the spot of conversations simply because you have a deep understanding of what that semantic context is. Before I did conversational AI, I used to work in large-scale knowledge management systems and kind of implementations of large content management systems as well. And I think one thing that we can learn from the content management system world is how these tools need to support an entire team. It's not just an NLU expert or a conversation designer. There's product owners that need to go in there and see analytics. There is content managers that don't care about conversation design, don't care about NLU, but care deeply about the phrasing of a specific phrase, and they should be able to deal with that. There is a conversation builder that is slightly unconventional, I think, because it's neither pure machine learning nor is it flowchart building, but it's this idea of designing electronic institutions with an engine that will proactively highlight issues as they come up. And all of this is actually packaged in an open source architecture. So you can dive into the very guts of it and plug in your own NLP interpreters, plug in your own knowledge graphs, domain knowledge graphs, and so on. It was really nice to see knowledge graphs mentioned as well, because we think that's another huge piece that makes conversational applications more robust. And finally, leaving aside the slightly salesy language of OpenDialog is the answer. What should be the answer for any conversational AI effort you're doing is that you need to be thinking about method together with the tooling. And whatever method you choose an appropriate tool for that method. Otherwise, you're always in tension. And while it is relatively simple to prove the value of conversational AI in one-off innovation projects, it becomes slightly more complex once you start thinking, well, conversational AI becomes a tool in our tool set that multiple business units are going to need to be able to support. But then the organization as a whole needs to ensure a certain level of safety and predictability in terms of how these conversations are going to evolve. And a lot of people mentioned how quickly machine learning specifically is evolving. I think that is incredibly true. And because of that, I think it's also important to be careful not to lock yourself into a specific AI technique. And just partly to please my own little, to scratch my own little itch, there's been a few mentions of what is AI and what is real AI, what is real intelligence, what is not. I'll give you a slightly different way to think of it and end it there. AI, artificial intelligence, is like mathematics or physics. It is a science. It is the science that attempts to understand what is intelligence, but it hasn't actually completely answered that question. So when you ask yourselves, what is AI? Replace AI with maths and ask yourself if you would be doing the same, if you'd be asking the same question. You have maths, which is 1 + 1 = 2, and that's maths. No one challenges that. And you have incredibly complex trigonometric maths with different styles of thinking about multiple planes and spaces and so on. And that's maths as well. So artificial intelligence is a science. It has a bunch of techniques that lead to capabilities like natural language processing, like vision processing and so on. And think about how you combine those techniques and worry less about, is it real artificial intelligence or not? The question is, does it solve your problem? And does it automate decision-making to a certain extent? And if it does, that's great. Okay, I will end it there.
Excellent. Thank you, Ron. It was terrific. There's a question from the attendees, confused by the term. What is exactly multi-agent conversation? What is an agent?
Right, an agent in the AI world is an independent piece of software that is able to reason, has its own goals, it senses its environment. So it can live in a purely digital setting, or if you think of a robot, any robot, that's an agent, right? So your vacuum cleaner that is automated and moves around the room and senses its environment. In a multi-agent system, that's an agent. If you had 2 vacuum cleaners and they had to say, okay, you do that part of the room and I'm going to do the other part of the room, that's a multi-agent system, and they've just coordinated and collaborated to solve a problem.
There you go. You know, you talked about humans and machines co-designing conversations. I think that's pretty close to the truth. How does that work? What approach do you think is the right one?
I think there is, you need to be able to give the machine an understanding of what is a conversation, what is a conversational model, what are its individual components. So in our case, we think of conversations in terms of scenarios that include conversations, that include scenes, that include turns, that include participants, that exchange intents, right? So we have that whole relationship between things. And then you can start reasoning about, okay, well, what happens if the expected interaction in a specific turn, in a specific scene, goes wrong? And you've actually not understood what the user said, or the bot was not able to complete a certain action, right? So you can start helping the conversation designer by saying, have you considered these options? And that's a first level of it. A second level of it is, because at runtime, you can be reasoning about how many times did people go through this specific turn or go through that specific scene. Is that within expected parameters, or is that an indication that something is going wrong? And the way we think of it is a deviation from expected behavior. What can we do to bring this back in line? Right. So there's a number of techniques like this that you can include to have part of the conversation defined by the conversation designer, and then part of it defined and managed by the machine.
Yep. Excellent. Excellent. I think they'll do it for today. So thank you for everyone for joining us today. I hope you found this interesting and insightful. I'd like to thank our speakers for your time. This is Jeff Logastro saying thank you and goodbye.